Hello, hi, I'm Dave Robinson, and welcome to another screencast where I'm going to be using the Tidy Models package to do predictive modeling in R. And as usual this summer, I'm going to be practicing on data from the Sliced series, which is an amazing series run on Nick Wen's Twitch stream, where where people come together and do predictive models and compete to see what the best they can do in 2 hours while being live streamed. So I'm going to be competing for my second lap of Sliced next week. So a week from tomorrow. I think that's what is that, Tuesday, July 13th. But today I'm going to be practicing with last week's submission. I haven't watched last week's episode yet, so I'm excited to share this and yeah, let's see what we can do. If you'd like to follow along, there's a link to this data, which is the NYC Airbnb listing prices. There's a link in the video notes, so you should be able to find it. And while I'm not going to be able to see people, well, in the actual episode, I'm not going to be able to talk along with people. Do feel free to chat if you're watching live. I can see you, and I'm always excited to hear ideas and strategies. It's a fun way for me to help to learn while I'm practicing for Sliced. So let's see what data we have set up this week. There it is. Let's see. All right. Root mean squared. Oh, logarithmic error. Okay, so this is going to be log of p minus 1. All right. Yep. All right. So one sec. Sorry. So what's fun about this? This episode is going to be root mean squared log error. I think that by adding to the predictive, I think that by adding one to the to actually load the prediction and the result, I'm going to be able to basically get around this, basically by logging in advance. So yeah, all right. And let's see. Okay, let's get the data. So we're gonna let I understand and accept. The data is going, and I'll show what I mean by root mean squared log error, working with that. So let's take a look at the training set. Let me download it and work from there. So it's about 5 minutes after the hour. I'm going to be coding for about 2 hours. So let's get started. So what I've learned is that it's useful to actually just start out with, I'm going to have to start with a blank screen. So I'm going to start by setting up all the things that I can think of, all the packages that I tend to work with. So I also like scales. I like theme set, theme light. Missing anything? Well, one thing I'm missing is do parallel, register, do parallel cores for to use parallel processing on my machine. Let's see. All right? And then what I'm going to do is read in the train data is read CSV, downloads, tag. What was it called? Sliced. I'm going to click it once, and then it should be able to slice episode 5, train. I actually don't call it train. I call this one Dataset, and I call this one holdout of the same thing but from test. I don't think I need the sample submission. And I'm actually going to do something to them right away, where, let me start by looking at our, so there's my holdout, and I tend to do set seed 2021, split is initial split. I'm out of practice. I'm typing as fast as I usually am. And let's see. Yes. Sorry. Thanks for people pointing out that I should zoom in. The problem is I'm doing this on a really large screen. I'm also going to save one, and so it's hard for me to notice. Let's see. I've been putting these in an ML practice folder, and I'll put F5. And how's that for people? People seeing things better, a little bit better? Well, let me know if this is still a little bit smaller. So the 5 and train is training split. Test is testing split. And great. That looks better. All right. So we've got 26,000 observations in train, and then 8,500 in test, and then in our holdout set, 14,000 that we're going to be predicting and uploading our predictions. So let's see a couple things. One is if I just look at, mostly name it's not like there's the same few people or something like that. This is going to be, let's actually read about it a little bit. What is it saying? Anything here? Nope. It's not. It's not telling me anything about the data. Ah, well, then we'll see what we can figure out from that. So the name. All right, we got a host ID, a host name. I guess I could try linking that to like male, female, neighborhood, group, and neighborhood. So this tends to be borough in the case of it's looking like it's boroughs. Neighborhood, longitude, latitude. That could be fun to do a map. Private, the room type, the price. We got a bunch of category. Oh, and the price we're going to be predicting. Let's double check on that. Yeah, this nope. It looks like no. Test says price, but what about holdout? Yep, missing price. Price is what we're predicting. We're doing log. It's a minimum nights, number of views, last reviews per month, and availability out of 365 days. Okay, let's look at a couple of distributions here. We have a lot of categorical. This is really I think it's a really fun data set. So let's start with let's actually start by looking at the distribution of what we're predicting, the price. Yeah, as I was hoping, this is logs on a log scale, but actually has some zeros in it. So the key is we're going to need to, we're going to actually transform the data right off the bat. So here's what I'm going to do. I'm going to say price is log of price plus 1. And natural, that's the natural log. And I'm going to do the same in the test set. Oh, pardon me, the holdout set doesn't have it, of course. So here we go. And now I don't have to do this. I can just, here we go. So we're going to be doing everything basically on a log scale. And that means that I actually like creating these functions where I do table where I'm going to do summarize, median, let's see. I can do average on a scale like this. So average price, and then I'm actually going to do X of price. I'm actually going to do the average price on a scale that I can understand, plus 1. So then n is n, median price equal x, mean price. So actually using the geometric mean, x of median price. I'm adding the 1 because I did minus 1 up there in the original data set. Sorry, plus 1, which means I actually need minus 1. Yay! All right. And median price, that's pretty good. Okay. And why am I doing this function? Because then I can say train and range descending n, train, summarize prices, the overall average price. Yep, so something's up with my mean. I did log, look at that. I did log of price plus 1. I'm going to do log of price plus 1. Here we go. Geometric mean 113, median price 105. All right, so so average price centers around 100. That's cool. But the main reason to do this is to do group by neighborhood, neighborhood group, and we learn a little bit about prices. We can say things like, all right, so I'll do median price by neighborhood group. And look at me spelling neighborhood as Americans do. I neglected to do. Yeah, so I can do things like, all right, Manhattan is more expensive than the other ones, but that might not be the best way to visualize this. I might want to start with doing it on, here we go, price, X price. This one, I want to see it on a, X for price, neighborhood group. I want to see it on a bar plot, a box plot. I want it on a log scale. Yeah, just want to see. Oh, okay. There is still some variation. So I definitely want to include neighborhood group. But I can also include. I can also include neighborhood. And I'm. Box plots are useful for these kind of categories. Too many neighborhoods, so I'm going to do an extra layer here. We're going to do FCP lump of neighborhood, top 40. Yeah, now we can see, like, okay, Midtown, always says Manhattan. and then Flushing at the bottom in Queens. So I live in New York City, for those who don't know. And yeah, I live on the, where am I? I live in the Upper West Side. There it is. It's a little bit above average, but there's really a lot of variation in all of these. And I guess it's because there's actually a lot else going on in terms of these apartments. So let's see what else we have. We have neighborhood, group and neighborhood. I'm not going to use host name yet. We have longitude and latitude, but I'm going to start with room type. Basically, I'm going to do the exact same thing I did here. How many room types are there? Just in case there's more than 40, I'm going to do it like this. No, there's only 3 types of room type. Entire home, private room, shared room. Still a lot of variation within each. So let's see the, and we already have price. We have, any text we're going to be parsing here? Only in the name, I think. Let me take another look at some of these. The minimum nights, number of reviews, last review, and reviews per month. I like reviews per month the most of these. Let's see. I like a lot of these. So let's take a quick look. So let's start with minimum nights. Actually, you know what? There's not going to be like a lot of these minimum nights. So I'm going to say minimum nights. I'm going to start like this. The it's not quite going to work. Price roof equals. This is not going to work. Nights, but because there's going to be some extremes. Yeah, you see those extremes. Those are those. Well, I know they make sense. They're just like they're people that like say seven plus, like people that require or give a sell for an entire month or something like that. What I'm going to do is I'm going to do p min of minimum nights and 14. And yeah, we can kind of see there's like a nonlinear trend where minimum nights beyond this point gets a little bit higher. It's really pretty hard to tell. I'm going to try this for a moment as a scatterplot, and with both. I'm going to throw in a low S smooth. Is there some kind of general trend here? I'm sure there is, like something. It didn't care for something here. Oh, I think it just didn't care that didn't like how my price should be fine. It didn't like this. And I don't want price on a log scale. Where is my geom smooth? I expect it to have a smoothing line on top of here. Not able to currently see it. So the, now let's see. I'm thinking about how to, group equals, yep, that was a problem. That worked for the box plot, but not for this. Let's try to get a sense of where the trends. Too much data? Maybe too much data here. Maybe that's the problem. Oh, something's crashing. Oh boy. Golly gee. Huh. Well, looks like I'm reopening. Oh, yep, crashed. Let's see how much I managed to save. Well, thrilling stuff, right? Oh, goodness gracious. Hey, look, I lost all my code. All right, sorry about that, folks. That's okay. I'll move back to where I was, where we were saying I did not save in a while, and I paid the price. Log of price plus 1. Oh, wait. Yes, I want to... there's all my code back. Wow, that was scary. The, for a second, I thought that I had to retype everything. This is not... yeah, whatever. Oh. My old session came back. All right, we'll see if it keeps working. Here we go. Oh, no. Why did I do the same thing that just broke it a second ago? Oh, man. Oh, man. That was like not even a little bit smart. That's okay. I'm going to pull this back in. All right. So bring this back, and all of this worked. Can I do head 10? Can I do head 50? Can I do sample N50? Can I do sample N200? This is how I'm going to make sure that nothing is crashing it. This low S was a little smooth, it was a little slow on all that data. Yeah, I don't feel like there's a huge trend here. I'm still going to throw it in when we do like an XG boost, but just worth kind of knowing. Now, how about number of reviews? Let's see the, actually. How about number of reviews, which I bet you, oh, no, I meant to switch this to LM. I meant to get rid of this at all. Number of views, not a, maybe a negative trend. Yeah, it's a little bit hard to see from these. I'll throw in a geom smooth method as LM. Flat. Look at that. Still throw it in because numeric ones are easy to add to like XGBoost or things like that. And oh, what about reviews per month, which I like more? Nope, still flat. All right, then the and calculated host listings count. I guess that's how many listings the host has. Probably. Let's find out. Is there a trend between that and? I'm just looking for like obvious trends. Now there could always be subtle ones. Calculated host listings count price. Maybe a tiny positive trend, could be statistically significant, pretty hard to tell. But a lot of these we can tell are on kind of a log scale. And then availability out of 365 days, let's see what we got. Probably positive, more availability means higher price. These zeros sure are weird. These zeros would be like, oh no, these zero availability, I guess that means it's offline. A lot of variation at that point. Okay, so one thing this is telling me is like, I think we can do linear models, some of these categorical ones, but I'm really going to be curious about like XGBoost performance on like the data as a whole. We can break down the names into money, and I might do that into words to tokenization, and I probably will be doing that later, but maybe not yet. I really want to do a map. Make a map. So we have longitude and latitude, which makes it easy to build like a really simple map. Because I can start with longitude, latitude, GeoPoint. That looks a little bit like New York. You've got the boroughs there. So I can throw in even like, you can see, oh, neighborhood, let's make the color be neighborhood group. And you can see 5 boroughs pop up, just because you want, there's Manhattan, there's the Bronx, there's Queens, Brooklyn, Staten Island. But it's going to be a little more interesting if I try making the color the price. And yeah, really hard to, definitely hard to see anything there. Let me try making the points smaller. Let me make them even smaller than that. And you know what I'm going to do? Is there are too many points here to see any kind of trend? Like maybe this is a little bit lighter, maybe this is also. So 2 things. I'm going to change the scale, and notice nobody's staying in Central Park. I'm going to do 2 things. I'm going to change the scale, and I'm going to actually aggregate this. So I'm going to say group by latitude and is round latitude to let me see to 2 digits. Let's try that. I'm not amazing at geography. Longitude 2. Summarize price is mean of price. See, get it down to fewer points. Now, let me try to 3. Too thin now. You can actually do like fractions. I don't know exactly how the rounding works, but no, too thick again. Yeah, let's start here. But secondly, I'm going to get the size back up. And also, I don't like this scale one bit. I'm going to scale color continuous, scale color gradient to low is red, high is blue. High is blue? No, low is blue. The price is by low is blue, high is red. I'm going to have to set the midpoint. You know what I'm going to do? I'm going to re-exponentiate these. So x and re-subtract 1. And that's no good because I need to say trans is log 10. Midpoint is actually still on a log scale. I forgot about that. And this, log 10, then the midpoint is going to be 2 at 100. Here we go. Yeah, so this actually, notice is getting a little bit better. Now I still need to add something, and it's definitely still not there. Can I do theme map? Yeah, that comes from the GG themes package. Oh, I never installed GG themes. Give me 1 second. All right. So you have to do theme map. Oh. When is going to work? Yeah, and I'm also going to add, let's see, New York City shapefile. I've done this before with Manhattan. And I think I might have done it once on tree dataset, but that one's not available. Give me a second to widen this up. Let's see. So what am I doing? I'm doing New York City shapefile. Borough boundaries. That's not enough. That's not enough. I want more than that. Let me actually use ggmap. And you know what? I actually used ggmap previously. Control-Shift-Find lets me find it. I remember I did this in Uganda. Here, I did it in the squirrel census. Yeah, look at that. But I'm gonna use ggmap. Yeah, and where did I get Uganda map? Gets map bounding box. Okay. Yep, let's give this a shot. That was always nice to remind myself what I've done before. Library ggmap is not something I use every day. Oh. I recently reinstalled R, so that's why I don't have it anymore. And all right, what's the bounding box that I'm going to be working with here? Let's do with range latitude. Here we go. So I can say left is, I just said latitude. So bottom is this, top is this. Just kind of getting the minimum and maximum of each of these. Left is here, right is here. Huh, that is not enough. Oh, the zoom is way too far out or too. If I try zoom is 12, here we go. Let's see how this looks. Too high res? We'll see. Wow, too high res. I'm gonna try 10. 11. That looks pretty good. What's great about this is now it can do like a GeoPoint on top of this, but this time with the data. So say, I don't know myself, is this the same way that I did last time? I did GeoPoint, yep, it's exactly what I did. So I do GeoPoint longitude, latitude, color. Data is what I call train. Uh, and I decided to aggregate it. So I'm going to say aggregated lat lon and use that data instead. Yeah, you know, it's like, it's not quite nailing it for me. It's not quite a nailing for me. What am I missing here? One is the fact that the midpoint is white is kind of confusing, but you can see, you know, I'm going to make it a little bit bigger. I'm going to yeah, you know, this isn't too bad. And the, let's see. Yeah, this isn't too bad. All right, basically what we're seeing, all right. So there's a couple tricks there. We aggregated and we're looking at like this red lower and midtown Manhattan, kind of this white like mid-priced range. Then we see these red areas of lower, no, sorry, red. Oh wow, there's a red area here. Yeah, but that could actually just be one problem here is that I don't want to say n is n and filter n is greater than. There could always be ones that have only like one price. Yeah. So filter out any dot that doesn't have at least 10. I'm going to make this just 5 to complete it a little bit more. Okay. And here it's like, yeah, we can see mostly by neighborhood. I'm actually going to try doing size is n. And size is number of listings. Oh yeah, that's looking kind of swell. I'm going to change the scale size continuous to be range 0.5 to 4. What we're doing there, I'm trying to make the biggest points a little bit smaller so they don't flatten things out. Yeah. All right, that's a solid map. And yeah, and what it's really showing is, I don't know if there's more information in location than the neighborhood group, but you know there might be because you're kind of doing this by region, and maybe doing a tree on this will turn out to be better than using neighborhood group. That's kind of cool. We can use latitude and longitude as 2 degrees in a model. All right, so that's some things we've been learning from this. Let's see what else we got here. Let's see, we did latitude and longitude, we did room type, we did calculated listing, homelessness count. All these are numeric, all of these are, oh, and last review, let's take a look at this, that review. Yeah, so mostly recent. So I can transform that into like days since last review or something like that. I wonder if that has any impact or anything. So I'm going to do GeoPoint. Geo smooth. I bet all these have like a little bit of impact, so it probably doesn't hurt. It's really hard to see any impact there, any change of a time based on last review. But yeah, all right. I want to start some. Let me see. It's good to really explore our features. We did some things like neighborhood. Did some things we've got. Yeah, I'm gonna do some modeling. And I feel like I don't. Do I want to start with a linear model? I kind of want to just like jump into. If I want to jump into XGBoost. Do some things with like you know, what if we jumped into XGBoost? All right, let's try this a bit. So the metric set, sorry, I gotta call it mset, is gonna be metric set just RMSE because we already logged it. We can do this. And now I'm gonna say, and I'm gonna also do grid control. So what we're doing is grid control is control grid. I forgot to load one more package before I forget. Control grid, and we're not. This is verbose doesn't work. Save predictions true. Save workflow true. Save. There was one other argument I need to remember. What I always like to do in control grid. Extract. I like extract model where I can grab the model out. I already did parallel. Okay, and yeah, let's see what we got. What was the most predictive thing when it just was by itself? I guess neighborhood group. No, room type was pretty predictive of price. Okay, so the I'm gonna call it. I'm gonna do one called fold. Train fold 5. Train v fold CV 5. I like to set seed. So it's a model setup, and now I've got it split, and let's do some cleaning on it. So what we do with the title models package, we recipe, price, explain by, and we start adding things. So I'm gonna do minimum nights and room type. Let's say, sure, the minimum nights room type and number of reviews and neighborhood group. Those are things that just make a, and lad, I'm gonna throw in, I'm gonna stick to these to get like a dummy model. It's nice to get a dummy model. And train is, train is train. Data is train. And what do? I do step log. I'm going to log the minimum nights with an offset of 1. We need to add 1 at the start. And I'm going to log number of reviews too. I can really log all numeric predictors, and I think it's going to be a while until that gets us into any trouble. You know, that doesn't actually matter for an extra boost, so I'm going to skip that. But I am going to do step dummy all nominal predictors, so turn, and I'm going to create a little function called prep juice. One sec. Create a little function called, so prep juice of prep of the, what does this do? Well, when you prep the recipe, you're training it on your original template data, and this is to see, okay, this is what I'm creating, just a couple of variables, price explained by everything else. It's like a solid start. And now I'm going to call this xgref. And I'm going to create xgmod. I just wanted to preview it. The model is going to be boost tree regression. And try is tune, and trees is tune. Those are the two kind of to start with. I like starting with learn rate is 0.01. Find that works for a while. And then you only really need to tune that once you've got a good model. And set engine XGBoost. And I do XG workflow is workflow, add recipe, all right. So now I'm going to do I'm going to do tune grid. I'm going to do some tuning on this data and say of this workflow on our train 5-fold data set, where the grid is going to be crossing and try. I like to do I don't have a lot of variables, so I'm going to try 2, 3, because I only have 4 predictors in the first place. And trees is, I don't know, I'm going to start with trees. You really can give a lot because it trains them all with the same few models. And metrics. Remember what the tune grid argument is called. Metrics equals is msec. So that's a setup of So that's like a setup where I'm trying out 5-fold training on just like two up to 1,000, and we're just gonna see okay, how's it do out of the box. XGBoost. Yeah, we have 24,000. I might try a version where we do a little bit less, a smaller data set. Because even with this really simple model, it's taking its time. Always a little bit frustrating. But once this is done, we're going to be doing auto plot on XGTune. Autoplot's great. It's going to show us what the what our learning curves look like. And I'm trying out like super minimal to start. There we go. All right, so one thing we know is too few trees, bad news, and then we're zeroing out at, what are we zeroing out at? Select best at 600 at try 2 and like 600, or what was that actually? Yeah, what I really want to know is actually tune collect metrics, arrange mean. We're zeroing out at 0.535. We can sanity check that and actually look at where was that? Where was that? I just had it open. What was it? It was slice. It was Kaggle sliced S1 EO5. Yeah, here we go. We could, yep, this is the one. We can look at the leaderboard and be like, okay, so that would put us near the bottom of the leaderboard just as like a cross-validated area. Yeah, makes sense. We're not looking at an awful lot yet. We're just looking at these, not even just like room type, number of reviews. Okay, let's so 0.535 with 0.535 with minimal version. Not amazing. So let's try out latitude, longitude, and neighborhood group. Not neighborhood yet. And let's try making it 2, 4, and 6. What I like to do in the other one, and yeah, I think I'm going to do in this one too, is I'm going to have a second one open of EDA. So I'm going to close this without saving because I don't want to lose the data in the other one. And I'm going to do new markdown. This is something I really liked. Yeah, it really did seem to work well. Is while I've got an XGBooster or some slow model training in one window, open up a second one where I do this this exploratory analysis, get a couple more ideas of transformations and things we can do. So grab the EDA so far. I've already got everything built, brought in. If not, I'll just make sure I do. Summarize, okay. Yeah, you know, I'm wondering with the text. Let me see, make sure, yeah, it's still running. Let's see, text analysis. Let's take a quick look at that one that we actually can be sent out of, like the name column. So if I did hide text, unnest tokens on name, turn it into words. Then you've got like, okay, you got like private. Some of these are really like obviously going to be linked to the to some of the other ones like private or apartment. We'll find out what the effect of cozy is. In fact, let's do that. Let's group by word, summarize prices. See what are these positive or negative? Wow. All right. So yes, room is already very negative. Bedroom, private, apartment, etc. A little bit positive. All right. Now, but I'm able to jump back. Sorry for jumping back and forth. Let's see what it's like when I have a deep this model where I trained a little bit more. You know, wow. I added a couple terms to XGTune, but did it finish running? Did I run all the? Oh no! I ran the exact same model again because I misspelled neighborhood. It was the same model twice. Oh goodness gracious! Yeah, so the I didn't even get all these in. That's okay. We're going back to this one. And what's actually cool about this? Head 30. I'm not doing stop words because I think some of these words are probably interesting. And average price. Remember, there's a geometric mean by word. Size is n. And word is FCP reorder. Average price. It's cool stuff. Words in a name do matter. So we are going to be using this, and we might we're bringing a linear model, and of course this doesn't actually prove that it. Some of these are just going to be like, oh yeah, if it says Brooklyn, it's probably in Brooklyn, and we saw the average price of Brooklyn was lower than Manhattan. Room is the smallest, but that is like a private type. so that doesn't it already is in there. Village, there's neighborhoods like the West Village, East Village, Greenwich Village that are all that are higher price. So a lot of this is about location. So that's one thing we can see. Cozy is small, means small most likely. So that's sort of worth knowing. But yeah, just keep checking back in. And that was maybe 50. Luxury is high, room is low, private and cozy are low, sunny is low. Yeah, cool. But again, and charming is somewhere in the middle. Okay, beautiful is somewhere in the middle. Certain adjectives are linked. Some of these are going to be again very redundant with location, but some of them aren't. Yeah, but let's rerun this. Let's run this first. We've got our model. Yeah, so it now 0.468. Once we add lat, long, and neighborhood group. All right, still flattening out. I don't need to go this far, I think, because I can actually, and one thing is all of them are really similar, so I don't need this many trees. And another is that I can get my models faster by going to just like 700. Yeah, I'm going to stay at like 2 and 5, do a bit faster, just like, no, I'm going to keep 246 for now, because I want to throw in a couple other things. And let's see what we got. We have in my train, we have reviews per month. Let's see, we got, I got room type, reviews per month. We got calculated host listings count, and availability 365, and a couple terms. Just to be safe, I'm going to keep it going to 800. This adds most of the numerics. It does not add name. This is missing. It does not include name, host ID, host name, neighborhood, as opposed to neighborhood group. It doesn't include, let's see, minimum nights. Did I say minimum nights? I include minimum nights, number of views. Last, I don't include, or let's see, last review. Okay, it does not like that spelling. I'm gonna still see, yeah, I'm gonna see how it does. All those went through. Okay, so in the meantime, I'm still looking at the words, and I see like, all right, there are positive and negative words. I'm gonna try this on a logistic regression in a minute. But first, I also want to see the effect of the neighborhoods. So sorry, of the not neighborhoods, of the host ID. So host ID, summarize price. This is So one thing we see here is that, of course, these are categorical, not numeric. Wow, there are really big differences between some of these top ones. There are really big differences. So I can treat this as a categorical variable, and yeah, let's try like add 50. GeoPoint average price. Average price and host ID, but make host ID a factor. And I should flip those two. And I should host ID is FCP reorder host ID by average price. One thing's hard to tell from here. Yeah, this is why I'm just look at the top 50. Instead of doing that, so someone's really pricey, I'm going to make a box plot. So I'm going to do mutate host ID is FCP lump, host ID 50. And points work, we're going to do a geobox plot. That long stretch there is other. It's so long, it's is thin enough that I'm going to decrease a bit. Okay, so wow, yeah, we actually have some real information here, and it would be silly not to use it as long as they do appear in the holdout set. So to do add host and text. Actually, host is probably what we're going to be adding next, but I'm going to be trying that out in a second. Oh yeah, so let's take a look at what we got. Still almost no difference. Maybe a 6 is maybe a little bit best. But let's see, 0.44. 44, you know, I don't know, all these are kind of close together. 444, once we add numeric use per month. I'm going to do a variable importance plot in a minute, but yeah, a lot of these are handy. Yeah, let me throw in host. Okay, so the next question they have around host, and go back to my EDA a second, is does the holdout set semi-join train by host ID? Does it have ones for the host? Okay, only 3,000 of them overlap with the training set. I think this is just very sparse data. Okay, so I can't get that much value out of host. And if I do, I'm going to get it only out of a couple of them. You know what? I'm only going to do host if I have a linear model set up, because just random forest doesn't tend to do well on this kind of thing. Unless I cluster hosts, I'm just thinking for a second of how to... No, the effective host is very linear. It's probably not going to interact with a lot of other things. So I'm going to keep... Yeah, I'm going to do a linear model later and bring in host. Add host and text and neighborhood group in a linear model. Okay, so what I'm going to do is do a, is there anything here missing? It's not those big categorical ones. Yeah, missing name, neighborhood, last review. Why not? What I'm going to do is I'm going to throw in last review, and I'm going to do, and was last review, yeah, I'm going to say step mutate. Last review is sys.data turned to days ago. And then also say step impute mean last review. I saw there was missing data in that. Actually, no, not impute mean. Why not? Let's impute. Obviously, yeah, last review is a little bit different than any other. I'll leave it as impute mean. I don't think it ends up being that important. But let's take a quick look at that. So if I do train mutate last and set this up. How many days ago was it? Last review lot in the same point, and we have a bunch of missing values. So I want to separate the missing values out. So I'm gonna step NA. Man, I can't. You know what I'm gonna do? I'm just gonna give them their own value. I'm gonna give them. I don't know. I'm gonna give them coalesce this with 0. I don't know. And the key is that now I can take this XGREC, I can prep juice it, have my data, and do what was the one I was just focusing on was last review. Yeah, just leave in all these zeros just as a separate category. This is categorical, so I'll be able to separate ones that have never had a review from ones that have had a review. So it's just something I can throw in, and at least maybe it'll add something to it. I'll throw that in, and I'm gonna change this to. I don't want to have fewer than 200. That's why this is looking so. The graph is looking so lame. Start at 250. And drop 2 because it was worse, and say 3, 5 and 7 and make this 25. Just do one final model fit where I don't include any numeric ones. Oh, sorry, pardon me, any categorical ones, which are host ID, host name, neighborhood, host name being text. For that, I'm going to bring in a lasso model, I think. How far are we along? We're closing in on halfway and on the 1 hour point. So I'm going to run that. In the meantime, I'm going to take a quick look. Yeah, so the, all right, actually, I should have done this as the full data. All right, because if we trade in the full data, only 4,000, then we'll have a host ID, but most of them are going to be very common. It's going to be a little bit weird. All right, that's the, let's see, yeah, the key that was going to be, we're looking at a couple of categorical ones, words, neighborhoods, neighborhood groups, and host ID. I'm not going to use host name yet. If I use that, I'll probably do male versus female. It could be an interesting analysis. You know, why not? It could be a gold feature kind of thing. There's a package. Gender. It's not necessarily very accurate, but it's an attempt to say the to predict gender based on names. I'm just curious for now, like, is there a difference here? And remembering how it works. I haven't used it in a long time. Yep. And what is gender? What is this? Then I see, okay. It would need year as well, so I'm not going to use that. Gender, so if I say, what format do I get back in here? Oh. Huh. It's not working. Oh well, I'm not gonna try inferring gender today. I don't think. It might have an effect on price, but it might not. And yeah, I guess it would really be one predictor variable. But yeah, I do want. Yeah, host name is probably just kind of a red herring. All right, so let's take one more look at our best version, at our ultimate version of the model. Yeah, one thing you can tell is that 5 and 7 are a little bit better. And it's kind of leveling off at 800, but it's not absolutely leveled off. Okay, so I can start with, I can do I can do it even a little bit farther. Okay, so so what I do is I would say XG, I'm going to fit this model. I'm going to do finalized version without categorical. So I'm going to finalize workflow with select best on XG tune. Is that right? Yep. And the fit on train. There's something I like to do here, which is I really want to see the root mean log square log error on the data. I mean, I can do this. Yeah, I'm just gonna do it here. I'm gonna do augment on test and RMSE on price versus dot pred. And yeah, 0.4428. And I'm just looking at the public data because that's what that. Oh, sorry, I should be looking at the public leaderboard. That's what was available. It's like, okay, that puts us around high on the list, and we'll see. We can upload and try this out. Before we upload it, I'm actually going to take a quick. And I would like to upload just like as an example of get set on the board. But before we do, I'm going to try a variable importance plot. It's the weirdest thing. I have to do it fit 4 times. I still don't understand exactly why. Oh. XG boost, XGB importance, model equals. Here we go. Affordances, I like to use gain, this Gini coefficient gain. It's a gain feature. Call, and let me do a little bit of. So this shows the importance of features in our model. Okay, standard knowledge. So actually, you know what's interesting is it's almost all the effect comes from Manhattan versus not, and like then this is using the Bronx as like because alphabetically first is the top level. So I might just turn this into a column of like, is it Manhattan? Maybe once you have that, because you also do have longitude and latitude to break down within the other boroughs. So that is interesting. Okay, so I might do that modification. Just and other than that, last review less important, but I don't know. It's a numerical. Available, it doesn't hurt that much. Private room, shared room, by far the most important. But all right, I am going to try this where I'm going to say step mutate is Manhattan is going to be neighborhood group is step RM neighborhood group. One other thing just makes it a little like that actually just removes a couple of the columns. I still again have latitude and longitude that I can work off of, and which did end up being really high on the list. So that's actually pretty cool, like using latitude longitude in a model. All right. And I'm going to try like one more go at making it even a lit. So that was one change, and I'm going to be a little more thorough in this. And say 4, 5, 6, and 7, and go all the way to 900, and we try this out. Oh, what did I do? What did I do? Something in the model didn't work. Did not like this. Oh. And what I'm going to prep juice. Last review was right here. That's last review. I'm confused. They put a comma somewhere that it shouldn't be. What happened there? This was step RM minus neighborhood group. Oh, this was that's step wrong. Oh, shoot. Minus, I removed everything except neighborhood group. I double negative that. All right. All right. The, I was just taking a quick look at the, all right, yes. Let's look at comments. Yeah, try running it through. Yeah, so this is me trying to be like as thorough as I can for an XG boost. I tried even a little, put it a little farther through. You know what? I'm only going to do this once, so let's do 1,000. Using the modification just based on this variable importance plot. Let's get back for a second. Now, I saw a question which is from Mr. Flick, which is, does head only bring back words that make the price the largest? What about price make them small? Well, the answer is actually that it was sorted not by price, but by N. Oops. So these are the most common words, and then this graph was showing of the 50 most common words, what is their average price. These are ones lower, these are ones higher. But we're not actually learning that much. This is like not, it's not doing anything on top of neighborhood and things like that. So it's going to be a bit of a, it's not going to be like a perfect model certainly. So I'm going to say this is F5 EDA. So what I'm going to do is actually fit a linear model. I'm going to do this myself. Yeah, what I'm going to do is grab some of this and say, I only want the ones that are somewhat important. So I want private, I want the room type, I want the neighbor, I'm going to use neighborhood group because I don't have latitude and longitude. So I'm going to say, what I'm going to do is and minimum nights with someone important availability. I'm going to drop last review. I don't think it's that important. And it's not linear. I'm going to drop review. Let me see. I'm going to drop number of reviews. I'll leave in reviews per month. Why not? And I'm going to keep latitude and longitude. I don't think they're going to really work. What I'm doing is fitting a linear version of this model with GLM net. Minimum nights, but the key is that I'm going to be adding in neighborhood, and not just neighborhood group, for hood, and host ID. And I'm going to do step mutate host ID is factor of host ID. And I'm going to do step other for both host ID and neighborhood. Threshold is if you're less than 0.001, you're not going to be counted. I'm going to drop these, put back in the logs, and call this linear rec. That's what it is. It's a linear it's a recipe for training a linear model. And I did a host ID, and though I almost forgot the words. Yeah, I'm going to throw the words in too. So I'm going to do name. Yeah, and throw the other things in. Mostly I kind of try and control for. You know what? I'm going to actually skip minimum nights and these. I'm going to skip everything that I'm not like interested in. I'll let the extra take care of that one. Now, you know what? Why not? No, because I want it to be uncorrelated. Okay, I like this a little more. I like to really focus on the runes. All right, and yeah. Okay, and I'm gonna do step dummy. Okay, so prep juice of lin rec. Oh, I don't have prep juice in this one. Where is it going? This probably crashed it. Well, let me jump back to this for a second. My plot of the tuning, number of trees just is not mattering here, but it does kind of keep leveling off. I don't know, so let's, and yeah, so I'll pick the best, and yeah, it does kind of keep improving. That's probably mostly overfitting one kind or another, even though it's another, so I'll just start, but I'll start with 1,000. Could lower the learning rate. That might get a better model. I might do that next. But wow, it's remarkable. Like the number of predictors really doesn't seem to make much of a difference here. Sure. Let's terminate this R. And yeah, just to check this. 427, what was it before? It was even like a little better than that, wasn't it? Oh, well. Can't trust that. You can't do everything based on this. All right, so I'm going to use this. I'm going to use this model, and I'm going to say, and yep. All right, so I'm only going to look at. I'm going to create a little function that's like predict holdout function workflow. So I'm going to do a little one. I just always find myself needing to do this. So I'll do, and what is actually the sample submission look like? ID and price. So what I do is say holdout predict workflow, predict on holdout, mutate price equals x of price minus 1. Yep. And then Yep, and then select just ID and, oh no, dot pred. Yeah, and the key here is that I should just be able to do right here, xgfit and where is my home? Where does not have an ID? Oh, yeah. I neglected to do one thing, which is find calls of, oh, I can actually do augment. There you go. And we got our price, it looks like it's on the right scale. Okay, so the, and is anything predicted for 0? No? Okay, cool. So take this, write CSV, traditionally I do desktop, so F5 attempt1.csv. Let's see how it is on the, I'm going to do it as a public, I'm not going to pay attention to my private submission because it wouldn't have the information in a competition. So what I'm going to do, and what it shows here is on the public data. So what's going to show here is, I'm going to say XGBoost with 1,000 trees on most non-categorical columns. 0.4. So again, on the public leaderboard I'm focused on here, it would be 0.4. It would have done well, but again, the public leaderboard doesn't really matter much. So I'm going to see if I can do better than that. I've got a little under an hour to try and do better than that. Two ways to do better. One is by further improving my hyperparameters, and another is by let's see, yes, by merging in a linear model that takes into account some of these other terms like the words and such, the text. Okay, so like enough. So all right, let's fit that. Let's bring in that linear model. So I'm going to do it here. I was starting to do it here, but got interrupted. Linear version on the categorical. So I think what happened here, my threshold was too low. Post ID in neighborhoods, let's see. What's confusing me is that I wouldn't have expected this to be that slow, because I meant this other should take care of like I think what's happening is this host ID is getting too wide, but I expect other to have taken care of that. So this is probably going to crash, and that's a little bit frustrating. Well, that's what I'm going to go in here and continue from here. Nope, I'm not. I don't want to do that. I lose all my ADA. Wait, hold on. Oh man, that was rough. Okay, let me try. Head 100. See my, oh boy, name. I didn't other the name. All right, oof, that's rough. Okay, yeah, that's what happened. All right, and now I've got this. What happened to longitude? Oh, I see. Step log. Oh, no, that's no good. I'm going to only step log. You know what? In this one, I don't have to. Latitude, longitude, and then all of these neighborhood groups, special 0.01, but at least it's logistic. Okay, so then the lin mod is going to be linear reg on and set engine glm net. Penalty equals tune. I'll even set a lower threshold for this one. Why not? And do, let's see, how's it look? Okay. And do then workflow is workflow set add recipe linrec add model lin mod. All right. So remind myself how to tune things. Seven minus 1.1. You can also tune the threshold. I'm going to do that in a second. In fact, I'm going to do it right. I'm going to do it as soon as this model is done. I'm going to say tune both penalty and threshold is, and I'm combining the threshold. I'm combining the threshold between. I'm using the same threshold on host ID and neighborhood, which is probably iffy, but. Yeah, what I'm doing is I'm saying, like, okay, if I keep only the really common ones, Autoplot, if I keep only the really common, like words, as opposed to if I keep at a host, as opposed to if I keep lots of them, how does the model improve? Now that I'm thinking about it, I think it's only 1 in 1,000 is going to be only make up like a handful of the results. So honestly, oh wait, this is 1 in 10,000. That's a terrible model. That's no good. I don't want this. But I'm going to do 0.03, 0.01, 0.03 as our thresholds. So it's like one of those is way too sparse. Like if it's 1 in 10,000, it's going to be at most to give information on one host in the other data set. Yeah. So I'm going to be curious at what are the performance of each of these? How does it depend on the penalty? Yeah, you know, interestingly, it doesn't. None of them end up overfitting, yeah, it's like you want low amounts of regularization. If it were overfitted, it would jump up again here, but none of them do amazingly. A little better than 0.5, but in fairness, they're only not using an awful lot. They're using most like neighborhood group and neighborhood and host ID. It does. Let me see. Yeah, okay, I'm going to try bringing in the name. I think, oh, but first let me see. Yeah, lin, tune, black. I think see, the smaller the threshold, the better. Okay, that I do want to throw in an 0.01. Yeah, we have this information on the host. Let's use it. How long I got? Yeah, like 45 minutes, a little, plus a little. Got plenty of time for this. So it's like, it really does look like, yeah, setting lower thresholds, at least for this set, seems to be a bit better. Wow, yeah, the lower the threshold, the better. And it's about 0.48. Just based on, what is that? That's room height, long lat, but long lat neighbor, which is linear and not going to look like an amazing model. And host ID. This doesn't include any interactions. All right, but the yeah, and then I can actually find out like what are the coefficients of each of these. Well, to do coefficients, I usually want to do step normalize all predictors so that I can compare the importance of them on a similar scale. It's not going to change the model, but here's what it does change. No, before I do this, I'm actually going to do one more thing and do step tokenize. Name, step token filter name, and I'll do max tokens is only say take the 50 most, make it the 100 most common. This is too high a threshold. This can be tuned too, but I'm not going to right now. I'm just going to say take 100 words. And now I've got neighborhood group, I've got the host, I've got all this, and I've got the oops. What's, yes, oops. Step TF on name turn into a term frequency. Oh, still not working. I never put in name. Name, token filter name. Yep, so turn it into term frequencies. Yeah, I'm gonna be interested in like how does this now with 100 words fit in. Maybe we see a little bit of overfitting. Well, we'll find out. It's remarkable that like how that this just does better. Yeah, improves it a little bit when I throw in the text. So I'm going to keep that. What if I say the threshold is this, and we do tune max tokens to 30, 100, 300. Make it throw in a 10. And make this tunable. Oh, shoot. Haha, I'm still doing train on, I'm only the first 100. Oh my goodness. Oh goodness gracious. I need to rethink all, I need to get back to all of these. So I do 100. Oh man, that's embarrassing. And I still do threshold 01 point 0.001, 0.01, 0.03. Start with. And it's still, wait, even on that doesn't really matter. Nope, it didn't matter because the size of the template data isn't what matters. It's this one that matters. Wow, okay, sorry about that. That only mattered for the example. Okay, so I can go back to saying threshold 0.01. I was wondering, like, it didn't make any sense that it wouldn't be overfitting if we were trained on something that size. Okay, I'm going to try tuning max tokens now. So we're finishing up this tuning of like the linear model. I don't think it's going to be as good as the XGBoost. I don't think it ever is going to be as good, but it's going to give us different. It could be giving us different information. So we could be doing an ensemble of these two. That could end up being better. What you can't do is you don't want to train models in two different windows because both of them are parallel across all four of my cores. So so they would actually slow each other down. So I can't like do XGBoost in one, mess with the linear model in the other. But yeah, here's my my linear version. Let's see. I try a couple of these. The threshold is on hosted in neighborhood, and the man, it really doesn't show much. It's like you always just want more tokens. Oh, they're at a 0.45. That's crazy stuff. All right, well, I'm going to try this. Let's do a linear fit. So lin fit is going to be lin workflow, finalize workflow, select best, lin tune, fit train. Wow, it does actually, in like cross-valid error, this does nearly as well as XGBoost, and it's exciting me because it might be doing it on different different data, so and like with a different purpose. That is like different. All right, that's actually really like cool. Okay, then this thing about what I think I'm gonna do. Yeah, I'm gonna blend them, but I really wonder like with tokens being, maybe I should have even like lower threshold, even more tokens. I'm worried I'm gonna overfit at some point, but let's try a little bit. Crazy to me, there's so little regularization happening. Yeah, I'm gonna try this with 500, and then I'm gonna keep moving on to the next step. The next step is I want to interpret these a little bit. I want to look at our linear fit and actually like say, okay, did I normalize? I normalized, all right, which means that I'm actually able to take this linear fit. That's a weird thing I have to do with this. Was again fit. It has to do with how these models are set up, and now I'm good, and I can start using the broom package. So I can say take this, tidy, and just filter. Well, this is actually the hard part is I need to figure out what the best lambda value is. It's not quite gonna match out of these. It might. I'm gonna see. It's taking its time. I think 500 takes its time, yeah. Yeah, this slowed it down. That's all right. There's a couple steps here you have to do, which is something like this. Oh, thanks. Yep. Yeah, finally with 500, there's a little bit of regularization happening. So if I did this, does this work? No. So what I do is I'm tidying this, getting the right lambda, getting, so let's say, what's confusing here is I'm trying to like pick just one lambda value, and it's like, it's not working. But yeah, it doesn't matter. The filter, I'm trying to get one lambda value, and I say term is not equal to intercept. That's a boring, it's not an integral one. And I do top n 20 absolute value of estimate. Let's make it 40. What are the most important terms? Term estimate, term geom call, mutate, Manhattan. We expected some neighborhoods to be at the top, but also a host ID, and yeah, the private room, shared room at the bottom, and longitude. I think is partly that like yeah, you can like you could actually see like the farther out you got into the Bronx, like the more east you went. Sorry, pardon me. The east you went into Brooklyn, the lower the price. So longitude getting higher means the price gets lower. That is, as you go east, the price gets cheaper. Manhattan's in the west. It makes some kind of sense. Yeah, and cozy's negative. And notice this is like yeah. So luxury is positive. 3 and 2 for the number of bedrooms is positive. Yeah, I think we're getting information here we can't get anywhere else. That is, we can't get from elsewhere in the model. So I think it is going to improve our predictions. This is me adding too many terms to the model. I'm going to clean this up a little bit and say fill is estimate greater than 0, theme, legend, position equals none. I like this. I just like this kind of look where it's like, does it make it positive or negative? This is still too many terms. This is cleaning this up a little bit, even though, you know, more than half that. Coefficient model, and yeah, like Manhattan, Williamsburg, Midtown, I'll bring it upward. Shared and private room, bring it down. Longitude brings more west, more east brings it down. Studio and room. Yeah, so I think we're getting a lot out of this. And it is control, like, notice you're not seeing term names that are like village anymore. And that's because that's largely, I think, controlled by the neighborhood. Like that strength all goes to neighborhood instead. So this I think is pretty, is a pretty interesting model. And yeah, we saw that in fact when we predicted it was nearly as good as XGBoost. And again, it's on mostly different terms. They're going to overlap though. So ensemble time. I wasn't able to do an ensemble when I did for with the categorical. All right. So the words. All right. So and remember, this is also like weighted by how often it appears because we normalized it. So that's this is like the most impactful ones. Townhouse, really positive. Okay, this is really cool. So name turned out to be, like the listing name turned out to be pretty important. The great thing about this is now I've got, completely forgot to do control equals grid control, and I did on the other one too. Now, where is that going to be a problem? Is because I'm not able to stack these yet. I'm going to add this in. I'm going to rerun this. And yeah, that's going to take its time. But yeah, all right. So I'm going to go ahead and move to this next step. Where I'm going to take the stacks, and I'm going to do. Let me see. I'm going to do lin best is lin workflow. No, lin tune filter parameter. This was a little easier, but I can do filter parameters. this is the best way I've found, is that stacks can be really slow when I try, when I give it like all the tuned versions, but it can be really fast if I, can be relatively fast when I say, choose the best one. I'm just letting this stuff run in the background with my new control, and just to check grid control, did do save predictions and save workflow in my original flow. Where did I do that? Save predictions, save workflow. Yeah, I'm pretty sure that's right. All right, and I take these, and the next steps would be stacks, add candidates, lin best, add candidates, xg best, and blend predictions. Just remembering kind of how this works. Blended, and then there's blended lin xg fit, where I actually fit each version. But I'm gonna get to that in a second. But yeah, I'll do this. I should go to the other one, do a little more EDA first. But oh good, it got onto the xg tune. That does take a while, so fit. And then do fit members. So what this does is actually it takes the best version of each of these, it combines them, and then puts them together to say, okay, I think we add this weight to this one, this weight to this one, and we get it with the best prediction. Just wondering now, yeah, is it going to know to do? Yeah, it's going to know to put them on. Yeah, we're in a linear scale, so it's a little easier the combination, the blending. Then it's going to fit them, and then I can take this. And I can predict, on the test data, and actually, yet to do augment and RMSE dot pred and price. So I can actually just evaluate the blended model as opposed to each of the individual ones. So to do that, it's okay that I'm waiting a little bit because I've got a few more steps. I'm not allowed to share code here, to save code, like come in with any code already written. So, but I always write this myself. I do augment dot, I'm going to show you library room, and figure out everything else with it. Augment dot stacks, yeah. Function stacks, x and I don't remember myself now. The yeah, I want to do this prediction. So I'll do x and data. Predict x. There's a thing here where I'm doing bind. Oh, I just tired of doing it myself. Bind calls of data and predict x on data, like where x is a stack workflow, and then where add any extra arguments in here. I think that's right. I think it's called stacks. We'll see. You know, I could have dropped some of these I'm trying. They don't matter a lot, so like I'm kind of just burning time here. And go back to my EDA one and say, what else could I have done with this? I did a little bit on the hosts. Oops. Yeah, it really is something. I wonder, is that host that was a positive term show up here? I can't remember which one it was. Maybe it was this one. Yeah. Oh, here we go. I've got my two models, and I do pick the best of each. This is the result of one fold, and let's see if this works. It's so much slower than I expected it to be. It does some bootstrapping behind the scenes, but I always find like it's out that fitting the models themselves is really fast, and then creating an ensemble, and I think it's relatively fast. I'm doing lots of parameters, but creating one ensemble. So it's not even fitting models here. It's just deciding how to combine these two. Anyway, what does this show? Hey, look at that. They got similar weights, and that's actually pretty nifty. I'm going to fit them both. And the key that I did here was by adding that augment earlier. I can say augment on test, where it actually will like apply both models, then add the predictions, and then I can do the RMSE on those. Yep, it's fit, and run itself is this class model stack. That's what it was called. Augment's a function from Broom, but I like to use it. Sometimes it's not always not always implemented. All right, so this is the best we have. Combine them. We lowered the RMSE by like 0.01, so it's a pretty good combo. So there's actually a trick that I do here, which is I take this linear fit, and it has this train. I put it in the whole data set, so I say lin, oh sorry, no, not on the fit, blended lin xg full data is blended lin xg, and then I change this to be the full data set before I do fit members. That way I'm actually training on the full data and hopefully get a little bit more power out of it. I don't know if this is like kosher, but the oh no, yeah, no, that's right. What I did is, yeah, see, because this is all done so far in just the training set, 75% of the data, but I can like train these models on the, but no, I can train them on the full data. And here, yeah, you know, can I do that within fit members? Huh. Go to the other window to read the descriptions. Nope. Additional arguments currently ignored. See, wouldn't it have been cool to like, yeah, I think this really should have like the ability to fit members on a different data set. Like blend it on one, but then fit on another. Wouldn't that be handy? But anyway, in any case, let's fit both the XG and the linear models on the full data. Predict, hold out. That's right. All right. Right. CSV. Blended. Let's see. F5. Attempt 2. Oh shoot! I meant to put it in desktop. Now let's try it out. The last one was 0.4, but that was only on 1% of the data. And let's try this one. So F5 attempt 2. I haven't been looking at blend of linear, categorical and text, and XG boost on numeric and lat long. No matter what it is, I am going to trust it more. Yeah, it is better, 0.38. I don't know what it is on the private leaderboard, but I can find that out by clicking there. I'm not going to do that. 0.387, so it got better than 0.4, but again, that doesn't really matter. What mattered to me was when I tried running this, and this was a little bit lower. Just give me 1 second. Yeah, 1 second. Okay, sorry about that. Should have started a model running while I ran off. Anyway, yeah, so this actually, yeah, this is pretty good. I'll tell you what I'll do. Since we have a little time, I'll do one last model where I'm going to say and I think so I think we're really close to the final model. I'd be pretty comfortable just exploring the data for the rest of the time period if I were in the competition. But I think I'm going to fit one more model. What I'm going to do is I'm going to see if I can get XG boost a little bit better by, let's look at this current one, XG fit. Yeah, my current. This is the current like best for. Oh, actually, take that back. I cannot. I might have changed a little bit that fit. You see what the RMSE currently is. Oh, the linear model beat the XG fit. I think that text just is really important. This is cool. Like I find that when you work with XG fit on like a really sparse text, actually Boost doesn't work that well, but this blend is a killer. Yeah, it's still 0.427. Let's see if we can get a little bit better. And the way that I'd like to get better really is by like, notice mtry is not really mattering here. There's so little difference. I am gonna leave in 5 and 7, but I'm gonna try messing a little with the learning rate. Actually, no, I'm just going to keep it 7. Learn, and I'm going to go a little bit farther. If I need to turn down the learning rate a little bit to make it a lot, make it learn a lot slower. So I'm going to start with this. Yeah. So the key here is that like is that this is kind of asymptoting at one point, but you can get it. You can like say, okay, I want to learn a little slower, but end up at a better place. So that's why I'm trying like out learning a little bit more with a like trying out a slightly slower learning rate, but running it a little bit longer, finding out will it end up surpassing it, and then we can try using that model instead. Yeah, if I were in the competition, I'd have about 25. I started a few minutes after the hour, so I took a little over 20 minutes to try other variations on this. I'm not going to do that today because I think we've spent a solid amount of time, and I don't want to like spend all my time squeezing out performance, especially when I can't end up on the leaderboard anyway. But I want to like try one variation here. What else can I change? I can change the tree depth. So the and that like the max depth of the tree. That's one that I actually don't mess with very much. But it could be that these like that I don't just want to change the number of splits I'm trying to each tree, but the maximum complexity of each tree. So that would be the other thing I would start to mess with if I had a little bit more time. But yeah, starting out without learning rate. Okay, while this is running and experimenting with this, I'm going to see one more go through of what are the things that we did today. So we looked a little bit. We just said, okay, price roughly log normal with some odd zeros, so we can use treat as numeric. The neighborhoods, Manhattan is a far standard. We're going to create a map that does a little bit more of that. Look as a box plot and kind of see like, okay, there's just a lot of overlap between the non-Manhattans. We looked by neighborhood and saw there's definitely signal in neighborhood, but we can get it out with longitude and latitude too, as we can see in a minute. But we looked at room type and saw, yeah, it's all about entire home probably really high, private room, and then shared room below lower than that. We see that linked up in the invariable importance and everything. We saw maybe there's some kind of like nonlinear trend with minimum nights. I think we did pop up a little bit. And played around with minimum nights. Didn't quite find the graph that I really like with that. But a lot of these, yeah, don't seem to have like, at least on a big scale, don't have a large effect. A lot of linear things, a lot of things that are pretty flat in terms of their effectiveness on price, like host listings count and availability 365. But one thing we really did see that where EDA really did pop up here and was pretty valuable was looking at where we saw, okay, there are neighborhoods like Bushwick or West Village that are high, but there's also terms like luxury, and there's ones like private and room that probably get like built into that room one, but there's ones like cozy versus luxury, and sunny and charming. It's ones that, and 1 bedroom and 2 and 3 that could be, and that could mean they could be indicating things in terms of size. Oddly, 2 and 3 are lower than 1 bedroom. But yeah, this is something that's kind of giving us a lot of hints, and it made me realize, oh yeah. And secondly, we looked at host ID, and we realized we're not going to learn anything from these host IDs, but I am definitely going to believe that the big one that some of them are really expensive and some of them are really cheap. Tend to be really cheap, and they tend to be pretty centered in, and that means, yeah, we can get some signal out of these repeated hosts. So just taking one more look. Aha, yeah, look at that. The learn rate, nope, it's basically end up at more or less the same place more or less, yeah, nothing to be gained out of authorizing learn rate. I don't think in this case. Try even lower learn rates, things like that. I'm not going to try that today. Yeah, I'm not even going to bother sending this through a new model. And yeah, but then we did the really fun EDA. So I'm actually going to move this EDA. How much? The text analysis. Yeah, I'm just going to move this EDA back into the main document at the end of our EDA, but before we make a map, because I really like this map. So we look at longitude and latitude, and then we realize, okay, I really want this plop on top of the map of New York. And we say, okay, and it was only locations with more than 10 prices. So we say, okay, Manhattan definitely the most expensive. There are more expensive areas and less expensive areas, even in Midtown Manhattan, and then it gets cheaper as you get into up to like Harlem and Inwood and such, and then into the Bronx, and then kind of cheaper out in and generally cheaper. And there is kind of a general trend where in Brooklyn, this is where that longitude like term really comes in. Is even within Brooklyn. West Brooklyn as opposed to East Brooklyn. Sorry, pardon me. Yeah, West Brooklyn as opposed to East Brooklyn. Called downtown Brooklyn, more expensive. Yeah, so a lot we learned from this. And then yeah, that was yep. Look at that, and then I looked a bit of other things like, okay, is there some effect over time? Not really. And we looked into XGBoost. The thing that I really liked is after a little bit of XGBoost, we were able to create a variable importance plot. I realized from that, okay, I actually want it is Manhattan versus everywhere else. And in the end, maybe I could have kept the other terms in. Maybe it would have been a little bit higher. But I think it's a reasonable. I do think this is a reasonable approach. All right, let's find out. If there's like 15, 20 minutes spare, let's find out how we did. So the private score was 0.43. I think that doesn't do too well. Let's see, 0.433. We would have been second. Yeah, under Data Lab, who was one, I think, a couple of previous ones, but ahead of most. I remember who. I heard there was a tie in this one. I don't remember the names of who was. Hold on, who was competing? I don't know what their usernames are. It was Michael and Josh. I don't know which of those, but yeah, what if Data Lab got so much better than everybody else? But yeah, I would have been 0.433 on the private. Now that was from the blend. If we use the linear model, 0.448. Oh, sorry, just the XGBoost by itself, 0.448. And we would have been about fifth place. Yeah. Where is that tie on the where was the tie on the private leaderboard from Mike and Josh? I don't see them. I don't know what their usernames are or anything, so I'm kind of in the dark here. All right, but anyways, yeah, this was our this was previewing NYC Airbnb prices. That was a blast. What did I learn from this experience? I think the biggest thing I learned was it doesn't hurt to jump right into XGBoost. I feel like I had more time to kind of get to know the model once I did. But this was definitely a case where if there's a lot of categorical data, it is good to create a separate linear model and blend it in. That's really what put this over the top. So yeah, I didn't do a lot of exploration. I wonder if I hit the golden feature. Okay, well, that's it for today. I am going to be competing in Sliced a week from tomorrow. That's July 13th at 8 p.m. Eastern. I am going to be live screencasting my own side of it, so please do join. And I hope you had fun. I certainly did. I'll see you in my Sliced episode next week.